All right, guys, in example 3, we're going to be solving exponential equations and learning about what it takes to solve an exponential equation. So in order to solve this kind of an equation, the bases have to be the same. So if I look at part A, I have a base of 4 on both of them. So 4 raised to the negative x is equal to 4 raised to the 2. Well, if I want them to be equal, then this exponent needs to be a 2 as well. 4 to the second equals 4 to the second. So I'm going to get rid of the bases. I don't care about those anymore because they are the same. And I'm going to set the exponents equal to each other. So negative x equals 2. Now I want it to be x equals something, so I'm going to divide both sides by negative 1 to get rid of that negative sign. And that'll leave us with just x equals negative 2. And I can put that in. And if I have 4 raised to the negative times negative 2, that's a double negative, which makes it positive 2. And we're good to go. Now, on part B, it's a little different because the bases are not the same. So we're going to figure out what the base is, and we're going to use prime factorization to do that. Now, I promise you, you probably have learned this before, but it may have been a little while. So we're going to break down 64 into its prime factors. Now, the first 5 prime factors are 2. Now, a prime factor has exactly 2 factors, 1 and the number itself. So if we look, for example, at 7, the only factors of 7 are 1 and 7. Now, we should not have to go up to 11, but that's the first 5 prime numbers. And what we're going to do is we're going to start at the lowest number and see if it's a factor. So is 2 a factor of 64? 2 is a factor of 64, and it's 2 times 32. We're going to break down 32 now. Once we know that our factor is going to be 2, that'll actually follow the whole rest of the way down. So 2 times 16, 2 times 8, 2 times 4, and then 2 times 2. So now we have all 2's. And how many do we have? We have 1, 2, 3, 4, 5 2's. So we can rewrite, we do have a 6th one right up here. So we have 6 2's. So 1, 2, 3, 4, 5, 6. So we can write this as 2 raised to the 6th. Okay, so 64 is the same as 2 raised to the 6th. Now we do need to keep this negative 3v plus 1. So that needs to be on there as well. So we'll have negative 3v plus 1. Okay, equals. And then we have 16. So we're going to break down 16. Again, is 16 divisible by 2? It is. So 2 times 8. 8 is equal to 2 times 4. 4 again, 2 times 2. So in this case now we have 1, 2, 3, 4, which means I can write this as 2 to the 4th. So 2 to the 4th is equal to 16. Well, now look at the bases. The bases are the same. They both have a base of 2. So now we can compare just the exponents. So we have 6 times negative 3v plus 1 equals, the exponent on the second one is 4. So just the exponents equal to each other. Now we have to distribute the 6 into the parentheses. We have 6 times negative 3v, which is negative 18v, plus 6 times 1 is 6, equals 4. To solve this two-step equation, the first thing we're going to do is we're going to subtract 6 from both sides. That's going to get closer to having the v by itself. So the negative 18v is going to come down, negative 18v, and then 4 minus 6 is negative 2. Next thing, divide by the negative 18. Remember, we're going to add and subtract first, and then we're going to multiply and divide second. So we're dividing by negative 18. We end up with v equals negative 2 over 18. Now, if I put that into Desmos, or if I know how to simplify it myself, it will simplify it. The negatives will cancel out and leave me with just 1 over 9. So that's going to be our final answer, 1/9. And so if they don't have the same base, make sure that they do have the same base before you go and try and solve them. These are year 2 problems to try out. If you guys have any questions, please let me know.